Good morning, friends, and welcome to another class. In today's episode, we'll be looking at solutions and their concentrations. I believe we can start. I'm sure by now you know what a solution is, and because you dealt with solutions when you were in the junior high school. But of course, we're going to look at these solutions once again, but we are particularly going to focus on the concentrations and how to calculate these concentrations of the solutions. So now, what is a solution? Usually, for a solution to be formed, you need what you call a solute. And this solute will be dissolved in what you call a solvent. So the moment a solute is dissolved in a solvent, you form a solution. Example of solute is, let's take salt, the solute. That's solid that will dissolve in liquid, solute. An example of solvent is water. Usually, it's water we'll be using for our solvents. That's why water is usually referred to as a universal solvent. So when salt is dissolved in water, you form a solution of salt in water. Usually the salt will dissolve uniformly in the water, what you call an homogeneous mixture. So solutions are actually examples of mixtures. Now, every solution has concentration, and the concentration of every solution depends on two main things. So, one, it depends on the quantity of the solute dissolved in the solvent. So, the quantity of solute. And when we talk about quantity of solute can be in two main forms, either in mass, it can be in mole. Because you can measure quantity in mass and you can measure in mole. So it depends on quantity of solute. Two, it also depends on the volume of the solvent. So that the higher, let's assume that the solvent is having a constant volume, the higher the quantity of solute you put in the solution, the higher the concentration. So now let's keep the solute constant. The higher the solvent, the lower the concentration. So the point is this: solution concentration depends on two main things, volume and quantity. The quantity can either be mole or mass. And in calculating for the concentrations of solutions, usually these are the things we look out for: the volume and the quantity. And the quantity can either be mass or mole. So we'll be looking at these three parameters and how we can use them to calculate the concentration of solutions. So now, solutions concentration can be calculated in two main ways. So it can be mole concentration and it can be mass concentration. So we have two main concentrations. You can have mass concentration and you can have mole concentration. Mole concentration is calculated this way. So it's represented by C. It's calculated by dividing the number of moles of a substance in the solution by the volume of the solution. That's how you calculate the mole concentration. The mass concentration is also calculated the same way. The only difference is that instead of mole, it will be mass over volume. That's how you calculate mass concentration. So here the mole is mole, mass is gram. The volume, please remember, is either dm cube or liters. And please, you need to remember this. The volume should always be in dm cube or in liters. So here too, it will be in dm cube or in liters. If it is not in any of these units, what it means is that you would have to do your conversion from whatever unit is given to you, either dm cube or liters. Dm cube is equivalent to liters. So you can use any of them. I'll show you how you can do this conversion very soon before we start looking at the examples. But the point here is this: to calculate concentration or mole concentration is always the mole divided by the volume. Volume is in dm cube. It is in liters also. Any of them. Mass concentration is calculated by dividing the mass, which is in grams, by the volume, which is also in either dm cube or in liters. Now, there are instances when the volume can be given to you in cm cube. So, for example, 100 cm cube. You need to convert this 100 cm cube to dm cube. How do you do that? It's very simple. To convert from cm cube to dm cube, just take the value given to you. Here in this case is 100 cm cube divided by 1000. When you divide by 1000, whatever you get will be in dm cube. So here, when you divide that by 1000, it will give you 0.1 dm cube. So remember, convert from cm cube to dm cube or to liter, just divide the value given to you in cm cube by 1000, and that's all you need to do. At your level for integrated science, you would usually be given, if you are lucky, your volume in dm cube or liters. That means you don't need to do anything to it. You need to use that value straight away in your calculation. You can also be given the volume in cm cube. In that case, you need to convert to dm cube by dividing by 1000 or using that volume. So I believe we can solve some examples. Yes, I believe we can solve some examples. So let's quickly look at some examples. So in the first example, we've been asked to calculate the concentration of a solution in mole per dm cube, in which, so let's put down the parameters. You have 0.5. So mole given to us in the question is 0.5 mole. That information has been provided. And the volume given to us in the question is 0.2 dm cube. Now, but when you read the question carefully, you realize that they asked us to calculate the concentration in mole per dm cube. Very important point. So remember, concentration can either be in mole per dm cube, can also be in mass per dm cube or gram per dm cube. But here you've been asked to calculate in mole per dm cube. So meaning you are dividing your mole by volume, and that is even easier. So and the information given to us makes it easier for us to calculate this kind of concentration. So concentration will be given by mole divided by volume. Remember, they asked us to find the mole concentration. That's why it's mole per dm cube. So we take the mole, in this case is 0.5 mole, divided by the volume. Before we use this volume, we have to be sure it is in dm cube or it is in liters. Luckily for us, this volume is already in dm cube, so we do not need to do anything to it. We just need to use it the way it is. That will give us 0.5 divided by 0.2 dm cube. So all we need to do is to divide the 0.5 by the 0.2. And when we do this, we will get 0. Sorry, let me just do that calculation properly. You do this, you're going to get 2.5 mole per dm cube. So that should be the concentration. And please remember, mole per dm cube can also be written as 2.5 molar. So mole per dm cube can also be represented by the um, unit molar. That's another way of saying mole per dm cube. So the answer is either 2.5 mole per dm cube or 2.5 molar. Molar is the unit for mole concentration. Mole per dm cube is also the unit for mole concentration. Let's look at the next example. In this example, we can ask again to calculate the concentration of a substance, but this time in gram per dm cube. So here, remember, we are calculating mass concentration, gram per dm cube. So here, the information given to us, we have mass, then we have volume. So let's write those details. So mass given to us is 5 grams, volume given to us is 100 dm cube. And here the question is saying calculate for the mass concentration, that's gram per dm cube. So mass concentration is still concentration. And what is it? Equals to the mass divided by the volume. Actually, we've been given the mass, so that's 5 grams. The volume has been given to us, but we need to be very careful with the volume. Is it in dm cube or in liters? It is in dm cube, so we are lucky. We can use it just the way it is. So divided by the volume of 100 dm cube. You don't need to do anything to this volume. So 5 divided by 100 dm cube, that will give us 0.05 gram per dm cube. So that is our mass concentration. It is 0.05 gram per dm cube. Remember, this is not the same as molar. Gram per dm cube is gram per dm cube. So let's look at the next example. In the next example, we've been asked to calculate the concentration of solution of NaCl solution in mole per dm cube. We use a different color in mole per dm cube. So mole per dm cube, it means that we are being asked to calculate the mole concentration. That's what we are being asked to calculate, mole concentration. All right. All right. That's what we are calculating. Now, the information in the question, we've been given the mass, we've been given the volume. So mass is equals to what? 5 grams. We've been given volume of 0.5 dm cube. Okay, so then we've been given another information in the question. That's the molar mass of sodium chloride. And that is 58.5. The question is, what are we going to use this molar mass for? So let's see what we'll be doing with these parameters given to us. So now we've been asked to calculate the mole concentration, but then we've been given the mass. But you and I know that for you to calculate mole concentration, you need the mole rather than the mass. So all we need to do is to use the mass given to us, determine the mole, then we use the mole to calculate our mole concentration. How do we do this? To mole, calculate mole is always equals to the mass over molar mass. I believe you've not forgotten this. We did this in a previous video. If you've forgotten, I would encourage you to look at it again. Go back to those videos and re-watch them. So that will give us the mass here is 5 divided by the molar mass of 58.5. When you do the mass, you get mole of what? 5 divided by 58.5. That will give us what? 0.085 mole. So now we know the number of moles. With this number of moles, we should be able to calculate the concentration. So now concentration we know is mole over volume. So with this, we take the mole, this is 0.085 divided by volume of that's been given to us, that's this one, 0.5 dm cube. Remember again, because volume is already in dm cube, we do not need to do any conversions. So we divide the 0.085 by the 0.5. And when you do the math, you're going to get mole concentration of 0.17 mole per dm cube. Very simple. So let's look at the next question. In this next question, we asked to calculate the concentration, but this concentration is in gram per dm cube. So what kind of concentration are we calculating? We are calculating for mass concentration. The mole has been given to us 0.5. The volume has been given to us is 0.3. So what it means is that we need to convert the mass given to us, sorry, the mole given to us to mass, because we are calculating for mole concentration. You know mole, let me first write, so mole equals to 0.5, volume equals to 0.3. Then let me write the molar mass of the molecule given to us. It is 36.5. Now we know, let me also, is there any other information? No. You know mole equals to mass over molar mass. So from here, you can do the change of subjects. That will give you mass to be equals to mole times molar mass. This is simple change of subjects. So that will mean that our mass will be equals to our mass will be equals to the mole, which is 0.5 times the molar mass of 36.5. So our mass will be what? When you do that calculation, 0.5 times that that will give us what? Do that calculation, you get 18.25 grams. So now we have our mass. With our mass, we can calculate for the mass concentration. You know, mass concentration equals to mass over volume. So our mass is what? 18.25 grams divided by the volume given to us in the question is 0.3 dm cube. Because it's in dm cube, we don't need to worry. We just use the gm cube the way it is. If it were to be any other parameter apart from dm cube or liters, then we need to do the conversion. So 18.25 divided by 0.3, that will give us what? 60.83. So that will give us what? Gram per dm cube. So that will be the mass concentration of the solution. Let's look at another example. So in this example, we've been asked to calculate the concentration of a solution containing this, containing how many grams? So 35 grams of potassium chloride in 5 dm cube of solvent. So mass given to us in the question is 35 grams. Then volume given to us is 5 dm cube. Then here we've been given potassium and we've been given chlorine. But we need to use those two to find the molar mass. So molar mass will give us the two added together. That's 35, 39 plus 35.5. When you add the two, what would you get? You add the two, you're going to get 74.5 gram per mole. So that's the molar mass of the potassium chloride. So we have the most important information in the question. But I will need us to pay attention to something. Here in this question, you realize that you were not asked to calculate any type of concentration, whether mass concentration or mole concentration. You were just asked to calculate concentration. Please remember, anytime a question asks you to calculate for just concentration, just assume that you are being asked to calculate for the mole concentration. The question doesn't specify the type of concentration you are dealing with. The assumption should be that you are calculating for the mole concentration. Here, you would have to calculate for the mole concentration. So first, we need to determine the number of moles. So number of moles will give us the mass over the molar mass. This is equals to 35 over molar mass of 74.5. So when you do that mass, you would get what? So you have, when you do that division, you get 0.47 mole. Now we have the mole. We can use that to determine our concentration. Concentration is equals to our concentration is equals to mole over volume. Our mole is what? 0.47 divided by volume. It's been given to us in dm cube, so we don't need to do any conversion. So it's 5 dm cube. So 0.47 divided by 5, that will give us 0.094 mole per dm cube. So that should be the concentration. And this can also be molar, 0.094 molar. So that's the concentration of this solution. Let's look at another example. So here we've been asked to calculate the concentration of a solution that contains this grams, um, 40 grams of dissolved in so volume has been given to us. The volume given to us is 150 centimeters cube. This is not dm cube. So first you need to convert to dm cube by doing what? You divide by 1000. So the volume will now be what? Instead of the 150 cm cube, it will be what? 150 divided by 1000. So that will give you what? That will give you 0.15 dm cube. So that's the volume. So now we know mass. The mass 40 grams. So what about molar mass? We can calculate the molar mass. Molar mass here, you add a 2. When you add the 2, that's 339 plus 127. That will give you what? 39 plus 127 will give you 166 gram per mole. Okay, so we know the molar. So with these two, we can calculate the mole. So our mole will be mass over molar mass. That will give you mole mass over molar mass of 166. When you do that division, you get 0.24 mole. So now we know the mole. We can calculate the concentration. Concentration is mole over the volume. So that will give us the mole of 0.24 divided by volume of 0.15. When you do that division, 0.24 divided by 15, you're going to get what? 0.61 mole. Let me write that here. It wouldn't go there. Mole per dm cube. So that's the answer. So 1.61 mole per dm cube. So that's the concentration of the solution. Remember here in this question, the volume was given to you in centimeters cube. So we first calculated from centimeters cube to dm cube. Alright, then we did that by dividing by 1000. Then again, we converted the mass to mole by dividing the mass by the molar mass, and we got mole. Then after getting the mole, we use the mole to determine the mole concentration. Remember, the question was silent on which kind of concentration we are calculating. Because it was silent, we calculated for the mole concentration, not the mass concentration. So I believe that will bring us to the end of today's lesson. Please subscribe to the channel if you've not done that, and share with your friends who are struggling with integrated science. We'll meet again in the next video. See you.